Ever wondered how large volumes of data are processed efficiently in your computer? Well, the secret lies in a method called batch processing. In the realm of operating systems, batch processing is a technique where data and programs are grouped into batches and executed without the need for manual intervention. It's like a well-oiled machine where every cog has a specific role to play. From the submission of jobs by users to the scheduling and execution of these jobs by the operating system, every step is meticulously planned and executed. And it doesn't end there. The system also takes care of managing resources, interpreting job control languages, and even spooling data to ensure optimal efficiency. Ultimately, the generated output is handled and directed to the necessary channels. All these components come together to create a powerful tool that excels at automating repetitive tasks and maximizing system throughput. So buckle up as we delve into the fascinating world of batch processing systems. Firstly, everything begins with what we call a job submission. Picture this: you've got a task that needs to be done, a program to be run, or some data that needs crunching. You're not going to do this manually, are you? Of course not. Instead, you'll wrap it up in a neat little package known as a job. This job is then submitted to the system. Now, how do you communicate with the system to tell it what needs to be done? The answer is through batch job control languages or scripts. These scripts are like the instruction manuals for your job. They tell the system what the job is, what it needs to do, and how it needs to do it. And that's it. You've just submitted your job. It's now in the hands of the system, waiting to be scheduled and executed. Job submission forms the first step in the journey of batch processing. After jobs are submitted, they enter the realm of job scheduling. This is where the operating system's batch scheduler comes into play, serving as a sort of traffic controller for jobs. It's not a simple first-come, first-served process. The batch scheduler organizes and prioritizes the jobs for execution, determining the sequence and timing of each job's run. It considers various factors such as job priority, the availability of resources, and scheduling policies. It's like planning a trip. You have a destination and a time to get there, but you also need to consider traffic, road conditions, and fuel efficiency. The batch scheduler does something similar. It looks at all the jobs waiting in the queue, evaluates the system's resources, and then plans the most efficient route to get each job to its destination. The scheduler, like a conductor, orchestrates the smooth running of the entire process. Once the baton is passed to job execution, the real action begins. At this stage, the job that has patiently waited at the front of the queue finally gets its turn. The operating system loads the job into memory, marking the beginning of its execution. But how does the operating system know what resources to allocate? That's where resource management comes into play. Resource management is the operating system's way of ensuring that each job gets what it needs without disrupting the balance of the system. It's like a master juggler, keeping multiple balls in the air at once, allocating CPU time, memory, and I/O devices to each job as required. The operating system carefully manages these resources, ensuring they are used efficiently and fairly. This way, no job is left wanting, and the system keeps running smoothly. So you see, job execution is where the rubber meets the road in batch processing. It's where the magic truly happens, transforming inputs into outputs and making batch processing an indispensable tool in our digital world. Ever heard of spooling and job control language? They play a pivotal role in batch processing. Let's unravel these concepts. Spooling, or simultaneous peripheral operation online, is a clever technique to boost the efficiency of batch processing systems. Imagine a situation where your CPU is ready for action but is held back because the input or output device is still busy. Spooling jumps into action to prevent this mismatch in speed. It temporarily stores data on a disk or other peripheral devices. This way, both the CPU and the input or output devices can work simultaneously, reducing idle time and boosting overall efficiency. Now, let's shift gears and talk about Job Control Language, or JCL. Picture JCL as a helpful assistant that provides essential instructions to the operating system. These instructions may include job requirements, execution parameters, and information about input-output files. The operating system interprets these instructions to execute the job correctly. For instance, JCL may instruct the operating system to allocate a certain amount of memory for a job or direct the output to a specific destination. In essence, spooling and JCL work hand in hand to ensure the smooth running of batch jobs. While spooling maximizes system throughput by keeping both the CPU and I/O devices busy, JCL provides vital instructions to the operating system, helping it understand and execute the job requirements correctly. So the next time you marvel at the efficiency of batch processing systems, remember the unsung heroes: spooling and job control language. They're the behind-the-scenes magicians ensuring that large volumes of data are processed smoothly and efficiently. Spooling and JCL are indispensable components that ensure the smooth execution of batch jobs. Now, who keeps an eye on all this? The job monitoring and control does. Just like a vigilant supervisor, job monitoring and control is the component of the operating system that keeps track of the progress of batch jobs. It's the one that stands guard, ensuring that all the tasks are marching along as they should. Let's say a hiccup occurs, perhaps a job error. It's the job monitoring and control that swoops in, handles the error and gets things back on track. It's like the superhero of the batch processing system, always ready to save the day when things go awry. Moreover, job monitoring and control doesn't work in the shadows. It provides feedback to users, keeping them in the loop about the status of their jobs. It's like your personalized update service, always there to keep you informed. So, in essence, job monitoring and control is the vigilant guardian that ensures everything runs as planned. Finally, the fruits of all this hard work are reaped in output handling. After the diligent execution of a batch job, the operating system is left with a bounty of output. This can take the form of reports, files, or other data, all generated by the hard work of the batch job. Now, the operating system takes on the role of a skilled archivist, managing and directing this output to its final destination. This could be a printer, eagerly waiting to bring the results to life on paper, or perhaps it's directed to disk storage, ready to be called upon when needed, or even sent through electronic communication channels, speeding towards its recipient at the speed of light. Regardless of the destination, the operating system ensures the output arrives safely and accurately. This stage, output handling, is the closing curtain on the batch job's performance. It's the final act in an intricate ballet of processing and managing tasks. Output handling marks the successful completion of a batch job. So that was a whirlwind tour of batch processing systems. We've journeyed through the intricacies of how batch processing systems function, from the initial submission of jobs through to their meticulous scheduling and execution by the operating system. We've seen how these systems prioritize tasks based on factors such as resource availability and job priority, ensuring an optimized and efficient process. We've delved into the importance of job control language, a set of commands that guide the system in executing the job correctly. We've also discussed the role of spooling, a technique that enhances efficiency by overlapping I/O operations with CPU processing. It's like a well-oiled machine, each component working in harmony to ensure the smooth running of the system. We've also explored how these systems monitor the progress of jobs, offering capabilities for job control and management. This includes tracking job status, managing job errors, and providing feedback. It's not just about getting the job done, but about ensuring it's done right. Finally, we looked at how the system handles the outputs of these batch jobs, managing the generated data, which can range from reports to files, and directing them to their appropriate destinations. Batch processing systems are the unsung heroes of our digital world. They might lack the interactivity of other systems, but their strength lies in their ability to automate repetitive tasks and process large volumes of data efficiently. They are at the heart of operations like payroll processing, billing systems, and batch report generation, silently working behind the scenes to keep our digital world turning. In essence, batch processing systems are about efficiency and optimization. They are designed to maximize system throughput, ensuring that every bit of processing power is put to good use. So next time you marvel at your computer's ability to handle large volumes of data, remember the unsung hero, the batch processing system. It's the silent, diligent worker that keeps the wheels of our digital world spinning.